Hi, my name is Robbie Owen. My thesis title is Isolating the Capabilities of Machine Vision, What Two Tests of Visual Shape Perception Teach Us About Machine and Human Cognition. I did my thesis under George Alvarez, and I am a neuroscience MBB concentrator. But first, the stakes. We are at an inflection point in human history and in the history of intelligence on this planet, especially with the rise of AI. We are approaching AGI, or artificial general intelligence, the point at which artificial models can be human equivalent on all intellectual labor. ASI, artificial superintelligence, the point at which artificial models can eclipse humans on all intellectual labor. And eventually the singularity, point at which technological development, accelerated by AI, is faster than we as humans can keep up with it. With all these in mind, it's important to be able to understand and isolate the capabilities of these models. Firstly, for their precise use as tools, but also for careful philosophical consideration of them as conscious entities. We can learn a lot about human cognition from AI models. We treat AI models as models, just as model organisms, just like Drosophila or mice. And in order to test these capabilities, we need to create clever tests, and we have to understand exactly what these tests measure. So here in this thesis today, we're looking at two tests of a model's ability to perceive shape and trying to separate and isolate what they actually measure. So the first test is the Nathan-Truda test, and this looks like having 6 different shapes and trying to isolate which one's individual, which one's the odd one out. And it turns out for humans, we have an increasing, if you look down the bottom right, we have a decreasing accuracy or an increasing error as shape complexity increases, whereas for models, turns out it's pretty equal across the board. Anyway, we can basically just see how a model, any vision model, performs on this test. And then we also have a second test, which is Garrow's shape bias test. If we look at the top right, we have 3 different images. We have an elephant skin, we have a cat, we have a cat with elephant skin texture. And we can look at the second measure measures how much of a model is shape or texture biased. So if you look at this image of a cat made of elephant skin, you go, what is it? If you go, that's a cat, then you'd be more shape biased in your classification. If you go, that's an elephant, you'd be much more texture biased in your classification. Turns out humans are pretty shape biased, most models are pretty texture biased. And so we're looking at whether these two measurements of shape perception, one in the geometric intruder test from before, and this one in Garrow's shape bias, they measure the same thing. We also have these special models called stylized image nets. Basically, what they've done is they train on this special data set, where you can see below this ring-tailed lemur. There's 10 different renderings of this ring-tailed lemur with different styles. And what this model is basically trained to do is to classify all these different images as a ring-tailed lemur, regardless of the texture, but purely on shape. And this model should, in theory, have a higher shape bias, and we should see how that also affects its geometric intruder test. And what we see here when we first look at our models, this is about 15 models, is that there doesn't seem to be too much of a connection. But we see the bottom right, we have the ResNet trained on the SIN. This is our style net. This is an outlier to be tried, separately plotting the style nets. And we see here that style nets in red, effectively what this means is that there doesn't seem to be a connection between shape bias and intruder detection accuracy. For style nets in red, there does seem to be a detection correlation for the regular models. And what this, where we read this and where we understand this, is that for the vast majority of models, because of the way that AI development as an industry works, is that most capabilities tend to come hand in hand. These newer, larger models up at the top right, such as DynaV2 Large, they tend to be more shape biased and have a better accuracy on the intruder detection score. Whereas all the small models are more texture biased, less shape biased, and also weaker. But with these style nets, effectively what we're showing is that you can dissociate these two capabilities, and they're not measuring the same thing. So in conclusion, shape bias and geometric intruder detection are distinct capabilities, and teasing apart similar yet distinct model capabilities can help us understand the mechanisms of cognition. As long as we retain humility and curiosity, we will learn from AI.